70 years ago, nuclear power was heralded as the solution to all of our energy woes, a clean, virtually inexhaustible source of energy that would move us away from our reliance on fossil fuels and pave the way for the atomic future. That was the plan, at least, as countries worldwide bought into the nuclear dream. Today, there are nearly 450 nuclear reactors around the world. In the UK, 15 nuclear reactors provide around 20% of the country's energy needs. And in the US, 99 reactors account for 30% of the world's nuclear energy generation. So keen were governments to jump on the uranium-drawn bandwagon that billions of pounds were invested, power plants were commissioned, and electricity was pumped out with apparently little in the way of a long-term plan. Because, it turns out, using radioactive materials to generate clean energy isn't actually so clean after all. While uranium might not pump out any nasty gases like fossil fuels do, it does leave behind a lasting legacy in the form of high-level radioactive nuclear waste. That same radioactivity that heats water in a nuclear reactor has a tendency to linger once that fuel is discarded. And by linger, I mean really linger, for at least 250,000 years. That means that the spent fuel can't just be washed down the sink or put out with the weekly bin collection. If we were to be exposed to it without protection, then the intense radioactivity would scramble our DNA, it would kill off cells and ultimately result in a pretty quick and unpleasant death. So it needs to be dealt with very, very carefully, which makes it all the more remarkable that there's still not a consensus on exactly how to deal with it. At the moment, spent fuel is stored in pools at the reactor sites for 10 to 20 years, where water does an excellent job of shielding the radiation and dispersing the heat that's produced. But it can't be left there forever, so a long-term disposal solution must be found. Currently, there are over 20,000 square metres of spent nuclear fuel lurking at the bottom of pools all over the world, which will need a final resting place sooner or later. It's simple. In theory, all that we need is for the nuclear waste to be sealed in a shielded container, and then that container put somewhere well out of the way for a few hundreds or thousands of years. The problem is finding somewhere that will remain sufficiently out of the way as our civilization continues to expand. Our oldest archaeological sites are just 10,000 years old, and their significance has long been lost to the mists of time. So how can we be sure that any nuclear waste won't be disturbed in millennia to come? There's no shortage of harebrained schemes that have been considered, and I should probably say rejected. You could blast it off into space, well away from Earth and its inhabitants, but launches can fail, and the possibility of radioactive waste raining down from the sky makes this a non-starter. You could bury it deep beneath the seabed, where miles of water and thick mud will shield the radiation. Or even better, at a subduction zone, where the movements of plates of the Earth's crust push it down deeper into the mantle. However, international conventions don't allow the disposal of any waste in our global oceans. And the thing about subduction zones is that what goes down tends to come back up, and radioactive volcanoes aren't really something you want to be starting. In fact, one of the most promising solutions is actually one of the most boring. Literally, I couldn't resist it. Burying our spent nuclear fuel in boreholes deep beneath the Earth's surface is probably our best bet for securely disposing of it for vast periods of time. These so-called geological disposal facilities would rely on the unbreakable, immovable nature of rock to completely entomb the potentially harmful waste for, well, if not forever, then at least for a very, very, very long time. But, sorry, we can't just dig a really big hole and throw in a load of fuel rods. Even disposing of fuel inside the rock can be a deceptively complicated process. First, the site needs to be selected. The ideal location is somewhere that is geologically stable, far away from faults that could rupture and cause earthquakes if drilled. The packaging of the waste is also important. To make sure it stays where it's put, the spent fuel is first encased in insoluble resin and then placed into thick steel containers. Several of these containers are put inside a steel or a copper sarcophagus, which is then surrounded by buffer materials specifically designed to absorb the radiation. The fuel's final resting place is in deep underground bunkers, which could then be backfilled with concrete to prevent any later disturbance. And the best way to avoid disturbance? Well, some developers think it's to intentionally forget about it. No signs or warnings. That could mean that future generations would simply lose track of where we left the radioactive waste. And that's a surefire way of making sure that it's not looted or intentionally interfered with. But there's that minor problem of accidentally stumbling across it. With facilities planned for nearly a kilometre down though, hopefully that's fairly unlikely. What's also unlikely, but not impossible, is that over the hundreds of thousands of years it will take for the radioactivity in the waste to decay away, the waste's containers may also decay away, leaving spent nuclear fuel sitting unprotected, ready for any passing water to wash it away. And that is most definitely not something you want. To protect against that, engineers have come up with an ingenious solution with a pretty cool sounding name. A hydraulic cage. Yeah, it works by surrounding the waste containing chambers with a layer of gravel. Any water that finds its way through the rock will find it easier to flow through the gravel around the chamber rather than flow through it. And that keeps the nuclear waste nice and dry inside. So yeah, bit by bit, scientists and engineers are overcoming the challenges facing the nuclear disposal problem. But the final and possibly biggest challenge is not one of science, but one of politics. Despite some really quite promising solutions for long-term storage and disposal, the public in many countries are still incredibly suspicious of all things nuclear, and political and environmental resistance has already put the brakes on disposal plans here in the UK and in Germany. Quite simply, people don't want to be anywhere near a nuclear waste dump, no matter how safe it's designed to be. As of 2018, only one country, Finland, has made any real progress in implementing a geological disposal facility, and that's mostly thanks to a major ongoing public outreach and finance programme. Back in the 1950s, nuclear power was the energy solution of the future, one that promised to fuel our graduation into a cleaner, more efficient and optimistic time. How ironic then that our attitudes to the not-so-shiny reality of nuclear waste are so archaic. Let's hope that Finland can pave the way and set an example for the rest of the world before we find ourselves knee-deep in radioactive waste. Because nuclear is, after all, a major source of power for many countries who have already committed huge amounts of money and infrastructure to getting that energy out, but who are then unwilling to invest the same in dealing with the waste that it creates. I would love to hear what you think we should be doing with our nuclear waste, so do let me know in the comments below. I'm also really looking forward to hearing all of your opinions on nuclear energy as a whole. Just remember to play nice, please, kids. Cool. As ever, don't forget to like and subscribe to BBC Earth Lab for more big science questions, and I'll see you next time.